Hello. Today I got a job in my shop where I have to put a couple of holes in this weldment, and the holes are located, there's two holes, and they're located off this surface and this surface. You can see in the drawing here, and that's a pretty straightforward job, especially if you have a machine with digital readouts. You just pick up your datums, move over to the hole location and put them in. The problem with this job is I've got the holes passed through these two plates, and relative to the size of the hole, they're a long ways apart. And this is always can be a difficult job if you have to get them lined up well. Sometimes if they're not too far apart, if the other one was just say here, you could drill through. This will stabilize the drill bit and you can drill through the second one, and I've had good luck doing that when they're not too far apart. But in this case, they're, one hole's 5/8, the other one's 3/4, and they're about 7.5 inches apart. So that's a pretty long distance for the diameter of the hole. This is the kind of job that is done quite easily on a horizontal boring mill with a rotary table. And what you do in that case is you have the part sitting on the machine, you come in and you picture, you drill those two holes and ream them to size, then you rotate 180 degrees and you just drill those holes again. And if you do it properly, they'll be in line and you don't have any long overhangs or anything like that. So it's a common method on jig boring machines and that, to have a rotary table and to place holes using that method. In some of my other videos, people have commented that the type of work I do, I should probably get myself a horizontal boring machine. And I agree. And a little while ago, I mentioned that I was looking at one that was for sale. And I, in fact, did buy it. And it has a rotary table built into it. And that would be the perfect machine for this job. Unfortunately, I haven't received it yet. I still got some work to do here to get ready for it, and I haven't had a chance to do that yet, so it'll probably be a few months before I get it. In the meantime, I have to get this job finished, so I need to come up with something that approximates a horizontal boring mill with a rotary table. And as David Wilkes would say, I don't have problems, I have a Bridgeport, or in this case, a good Taiwanese copy of a Bridgeport. So what I've done is I've come up with this setup here, which approximates a horizontal boring mill with a rotary table. And the way this setup works is, we know that the holes I've just drawn in marker here are located off of this and this surface. And what happens is when you rotate this fixture 180 degrees to get at the other holes, this datum shifts, it moves over, and therefore you can't use your original, you pick these up and pick that up, you can't use this original position to position the holes on the other side because it will move after you rotate. So what you do is you pick up that position the way it's sitting now, and then you rotate the table 180 degrees and you pick that position up again. Now if you have digital readouts, and those digital readouts have a tool offset storage function, it makes it really easy because you can just pick that datum up, call it tool number 1, rotate the table 180 degrees, pick it up again, and store it as tool number 2, and then you just got to remember which tool number offset is for which side. I don't have tool offsets in these readouts, they're older, but they do have an absolute and incremental function on them, and I never use it for what it's intended for. I only ever use that as a way to store two different datums, and that's what I've done in this case. So what I did, I've already done one of these. You can see the holes are in place there. So what I did when I was setting this up is I already stored this position, and and the other one. Now, right now, I've got the table at 0, and I've written absolute, and that's just to help me so that when I turn the table and I see it's got absolute written on it, I look at my readouts and see if the absolute button is highlighted. And if it is, then I know I've got the right datum preset. Just to help me so I don't get buggered up when I'm trying to remember what I'm doing. If I rotate, once I rotate this 180 degrees, you can see I've written incremental, and then I just come here, hit the incremental button, and now I can see my datum is shifted, and I won't use the wrong datum for the wrong side this way. But anyways, so that's the method. Where you see this done a lot, if you're interested in this type of work, is a YouTube channel called, I think it's called The Metal Raymond. I believe he's from Spain. Most of his videos are him doing work on a horizontal boring mill on large weldments, things like that. And if you're kind of interested in this kind of work, it's a fascinating channel. He does some pretty neat stuff on there, and I've learned a lot from him. And I'm going to continue watching that channel, especially after I get my own boring mill. I think I'll learn a lot from him. But anyways, I will go ahead and drill these holes. The first hole I'm going to do is this one, and its location is 1.131 inches on the z-axis and 3.745 on the y. And you can see that I've moved there already, and kind of in line with my marker. And I'll just center drill. Spot the hole. Now, the second hole, the Z is 0.718. And the Y is 2. Move the table out of the way so when I rotate it I don't strike the spindle. Easy doing one-handed with a camera in one hand. There. Lock the table and then change the incremental absolute to the new datum point. And then just repeat. Now I'll just drill off in the opposite direction just because I already have the knee at the right elevation. That's one thing, that you don't have to adjust the height of the knee when you change from one datum to the other. It's not affected by the rotation of the rotary table. So 0.718 and 2 inches. You can see how much I have to move to get to the same hole I just drilled because of the rotation of the table. can see a slight movement in the Z-axis when I drill, and that's simply because I'm pushing sideways on the table and it's trying to rock the knee over, and that causes the Z-axis readout bar to register a slight change in elevation, but it's pretty minor. I'm not too concerned about it for this job. Alright. The next hole is 3.745. .131. And that's all there is to it. The holes on this side should now be pretty much perfectly in line with the holes on this side. The rest of this job is just doing exactly the same order of operations, but with different sized drill bits and reamers in it, which we've all seen before, so I'm not going to show that. But yeah, so this is my setup. We limp along until I actually get myself a proper horizontal boring mill with a rotary table, and hopefully that'll be here in a few months. A couple of things I had to do with this setup, because there's a bunch of things hanging off my head here, my power drawbar and that. I'm limited as to how high I can bring the table up, and if I had had the rotary table sitting on the mill table, this would have struck the table before I would have got to the right elevation for the holes. So I took the table off my shaper and I used that as a spacer to get it up in the air. It's higher than I needed, but everything else I had wasn't high enough. So now one of the issues with this is you got a lot of overhang with a lot of weight. The rotary table weighs about 150 pounds. That shaper table has got to be at least 100. The rest of the stuff's maybe another 20. So I'm getting up close to 300 pounds, you know, and it's way outboard here when I'm working. And it's even more so once I have the drills and reamers in. They stick further out of the spindle. And anybody that has one of these mills knows that when you have a bunch of offset weight, the Y-axis gets hard to turn. That it binds up the dovetail. So what I did to counteract that was I added a bunch of weight out on the other side of the table. And even though the total weight on the table is quite a bit higher, the effect, I believe, is much easier on the machine. The Y-axis moves very easily, just as though there was no weight on the table at all. And it's simply because the table is much more close to being balanced. And it seems to work a lot better, and I think it's a lot easier on the machine. So it's something to keep in mind. If you have to have a big, heavy offset load on these tables, try and counterbalance it with some extra weight. The horizontal boring mill that I'm getting is a Wotan B75M, and it actually has built-in outriggers on it. For those who know what a horizontal boring mill is and what they look like, it's got built-in outriggers, so the table is actually supported pretty much directly to the ground everywhere in its travel. So you won't have these issues of, like I do here, with a bunch of weight out to one side making the one slideway bind up. But that'll be in a future video. Anyways, thanks for watching. Bye.